Welcome to maths class. Today we're looking at conditional probability, and I've written the word given there because given is a word that we'll see in lots of questions involving conditional probability. So what is conditional probability? It really talks about, quite often we have two categories or two steps in an experiment, and if I know the outcome of one, then that's going to change the probability for the other thing. So let me show you an example. If I toss a coin twice, I can draw a tree diagram like this, okay? This is my first outcome. I can either get heads or tails. Second toss of the coin, I can either get heads or tails if I got heads first, or I can get heads or tails if I got tails first. Now in this example, it doesn't matter what happened here. What's the probability of getting heads the second time? If I started with heads, getting heads the second time is a probability of a half. If I started with tails, getting heads the second time is a probability of a half. But that's not always the case. Remember, in sampling without replacement, what happens the first time changes what happens the second time. So let's think about this situation where I'm pulling some balls out of a bag. I've got 4 red balls and I've got 3 black. So what's the probability that I pull a black out the second time? Well, that's going to depend on what happened the first time. The probability that I pull a black out the second time, given that my first ball was black, is 1/3. The probability that I pull a black out the second time, given that my first ball was red, is 1/2. So probabilities where I tell you in advance what my first outcome was in order to work out this or this, that's conditional probability. So I would write this as this one here as the probability of black given that black happened first. All right. I should say black second given black happened first. And here, this is the probability that black happened second given that red happened first. Now, this is just notation. Don't worry too much about it. The point is, I can't just say what's the probability of getting black the second time. I need to know what happened first in order to answer that question. This is just the idea of what conditional probability is. So if we know that black was the first ball selected, what is the probability that black will be the second ball? If I go back to my tree diagram, if I know that black was selected first, the probability of getting black the second time is 1/3. All right, that's the nature of conditional probability questions. Now this is what it looks like in a Venn diagram. In this Venn diagram, I have 25 students in a class, and some of them study French and some of them study Japanese and some of them study both and some study neither. Now, if I choose a student who studies Japanese at random, what is the probability that they study French? Now, you've got to look at this first part. I choose a student who studies Japanese, so I already know that they're in this circle here. I'm not choosing randomly from the class. I'm choosing randomly from these 10 students who study Japanese. What is the probability that they study French? The answer is, well, there are 3 students in that circle that study French out of a total of 10 students. All right. So this is conditional probability. I'm not choosing from the whole group. I'm only choosing from the people in this circle. Now let's just talk for a minute about some of the language and notation of conditional probability. We look for the word given. I haven't been using it so far, but usually in a probability question involving conditional probability, the word given will be used. For example, what is the probability of drawing 1 ball of each color given that the first ball was black? Okay, that's an example of a question. So I know that the first ball was black, and what I need to answer is now, what is the probability that I get 1 of each color? In other words, the second one has to be red if I go back to that ball out of a bag question. In this question, This notation, probability J with a vertical line F, this vertical line I read out as given. Probability of J given F means the probability of J happening given that F happened. In fact, that's not what we talked about, did we? We talked about the other. We talked about the probability that the student studied French given that we knew they studied Japanese. That's the notation. Okay, now we've looked at it informally. Here's your formulas. We've got two formulas here, and let's talk through them. The probability of B given A, that's my conditional probability notation, is equal to the probability of the intersection of A and B divided by the probability of A. Now let's go back to my French and Japanese situation. This 3 is the probability, this 3 is the intersection here, and the 10 on the bottom is just the probability of Japanese happening. All right. Now, as probabilities, it would look slightly different, but I've used the numbers here and it works in the same way. The number that study Japanese So now here are your formulas. We have conditional probability formula is the probability of B given A is the probability of the intersection of A and B divided by the probability of A. And we have to notice here the probability of A is not equal to 0, and that's just because it's a denominator. We can't have a denominator of 0 ever. So that's there as a formality. You won't be asked a question where the probability of A equals 0. Just focus on this part. If you need to know conditional probability, you need to know the probability of the intersection divided by the probability of A. Now, A is the thing we are given. So you need the probability of B given A, you need to know the probability of A and the probability of the intersection. We can rewrite this if we need to calculate the intersection and we know the probability of A and we know the probability of B given A. And I'm going to demonstrate how we use these formulas with two worked examples. Here's my first worked example. If the Venn diagram shows the number of students in a class of 20 who like noodles or potatoes. So we can see I've used N is noodles and P is potatoes. I've got 8 students here in the intersection, 5 liking just noodles, 4 liking just potatoes, and 3 that like neither. Okay. Now, a student is selected at random. What is the probability that the student likes noodles? This is not a new skill. We know how to do this. In order to calculate the probability that the student is in the group N, they like noodles, is the number of students in the group N over the number of students altogether, which is the number of students in the sample space. So how many students like noodles? That's 8 plus 5. That's 13. How many students are there altogether? It tells me up here, but if I add these numbers to check, I will see that they add up to 20. So the probability a randomly chosen student likes noodles is 13 out of 20. All right, the second part of this, what is the probability that the student likes noodles given that they like potatoes? Now look at this word given. We always look for the word given. It tells us we're using conditional probability. So the first thing I want to do is write this down in probability notation. The probability that they're in group N for liking noodles, given that they like potatoes, they're in group P. So let's go to my formula. Probability of B given A is this, but I don't have B, I've got N, and I don't have A, I've got P. So I need to match up this with my original formula, okay? So on the numerator, I'm going to have the intersection. I need the probability of N intersection P. On my denominator, I have to have the probability of A. Now, which is that? Is it N or is it P? Well, it's the one in the second part of this formula. So I need the probability of P, the second part of this formula. This I can do. Now it's been simplified for me. If I think in terms of conditional probability, I'm not sure what to do. If I use the formula, I know how to find the intersection. I know how to find the probability of P. So I just need to squeeze everything onto the screen. I can't quite do it. The probability of the intersection is going to be the intersection number, which is 8, over the total number of students, which is 20. So that's 8 over 20. Over, I've got a fraction in a fraction. It's going to get messy. The probability of P, well, how many students like potatoes out of the total number of students? 8 plus 4 students like potatoes, that's 12 out of a total of 20. So I've got 12 over 20. Now, when you've got a fraction over a fraction and the denominators are equal, I can just cancel the denominators. And that works if you look at it this way. This is really the same as 8 over 20 divided by 12 over 20, which I would do by flipping the second fraction and changing this to multiplication. And those 20s cancel, okay? But I don't need to show all that working. I'm just going to cancel the two denominators, which leaves me with 8 over 12, which is 2/3. Now, I could have done this without going back to the formula. What I could do is answer the question in a more intuitive way. If I know that they like potatoes, what is the probability that they like noodles? Let's circle the students that like potatoes. Okay. So I'm not dealing with 20 students. I've only got 12 students to think about, the ones that like potatoes. What's the probability that someone selected from that group at random likes noodles? 8 of the students in the red circle like noodles. So my answer is going to be 8 over 12, which is what I got here. So the formula comes from our intuitive understanding, but you can go with this if you're more comfortable with that. You can go with this if you're more comfortable with that. Sometimes you won't have a Venn diagram. You'll just have numbers and you'll need to go with this. So make sure you practice both. Okay, my second worked example is going to look at, is going to look at this version of the equation where I'm looking now for the value of the probability of the intersection, but I'm given this information. But this worked example is also here to talk you through the process of reading a question and pulling out the information in probability notation and understanding. So I'm going to read through the question and look for keywords and important information. In a survey of shoppers, the probability that they drove to the shops is 17 over 20. Now, even before I go on, I've just been given some information. I'm going to jot it down. I'm going to let D be drove to the shops. So the probability of D is 17 over 20. Let's keep going. The probability that they are accompanied by children given that they drove is 5 over 17. There's that word given. I'm in conditional probability. They are accompanied by children. I'm going to let C mean that there are children. Okay. And I've been told the probability that they are accompanied by children given that they drove is equal to 5 over 17. Now, what does the question need to know? The question is, it's always a good idea in these types of things to actually jot down what's being asked. What is the probability that a shopper chosen at random drove and is accompanied by children? This and tells me that I've got an intersection. That's what I'm looking for, the intersection. So the question is asking for the probability that they drove and are accompanied by children. So let's see how that matches up with the formula that we know or that we've been given. When I want the intersection, I need the probability of A times the probability of B given A. Now remember that this A here, the second part of this formula matches this A. It's not the probability of B times B given A. It's A times B given A. So this has to match this. And that's what I've got here. I've got the probability of D, and I've got the probability of C given D. Therefore, I will be able to calculate the probability of the intersection. So the probability of C intersect D, I've rewritten it the other way around, it doesn't matter. C intersect D, D intersect B, it's the same, is equal to the probability of D times the probability of C intersection D. Okay, that's 17 over 20 times 5 over 17. These cancel, leaving me with 5 over 20, which is 1/4. Now, it doesn't matter whether I can visualize this in my head. I just need to go back to the formula and use the formula the way it's written. Now, can I point out that I could also write this as the probability of B times the probability of A given B. Doesn't matter which one I've got, as long as this matches the second part, the thing that we're given. The probability of B times the probability of A given B. All right, so I could have used the probability of C times the probability of D given C, but that's not what the question gave me. I have to use what I'm given in the question. So I jotted down what I was given, and then I put that into the formula. Okay, so that's our conditional probability.